Hi everyone, we're Team mathghost, and today we're going to present our final project for the NLP project. And our project consists of three major parts: a question generation part, an evaluation function, and a question answering function. And before we get started, let's just introduce everyone with the linguistic background that we'll be using. So there are three concepts that we used in the question generation part. First of all, the subject auxiliary inversion, or SAI. This is the standard English binary question formation for the closed class of auxiliary verbs, such as be, have, and do. SAI generates questions by inverting the subject and the auxiliary and keeping the remaining structure in place. The second concept is do insertion. Do insertion is the analogous binary question formation for non-auxiliary verbs. This process works by inserting the verb do with the matching inflection to the existing verb of the phrase, and then changes the original verb to an infinitive and perform the SAI. Finally, WH insertion is the question formation technique for WH words. This process works by first performing the appropriate binary question formation and then replacing a subphrase with an appropriate WH word, and then we move it to the front of the question. So in the generation function, for each sentence, we first tag and tokenize the sentence. Then we use the dependency tagger to identify the subject, which is the token marked by the end subject tag, and it's the sentence. We also identify the verb, which is marked by the root tag, and then we identify the rest of the sentence. Then we determine if the sentence has an auxiliary verb, which is marked by the aux tag, and if so, we do the SAI, and if not, we do WH insertion and do insertion. The resulting question will be returned and evaluated. So we designed this evaluation function in order to improve the performance of the question generation part. So in the evaluation function, we evaluated our question using three different methods and then linearly interpolated the results from those methods. First of all, we kept a database of questions, score pairs, and performed an altered version of Levenstein distance based on dependency parse tree in order to find the closest sentence in our database to our question. We then returned the scores of that closest sentence. After that, we compared our question to the document from which we generated it to determine the semantic relevance. This was done by a part-of-speech tagger to determine important parts of speech and comparing these words with the document to see how they matched up. We also give bonus points if our question used synonyms of words that appeared in the sentence. Synonyms are determined by using the species word vectors. Finally, we perform a simple check on the part of speech of the question to determine if it matched syntactic structures that we liked. So the final part of our project is the question answering part. So for this part, we first use the spacey part of speech and dependency tagging to find out the subject, verb, and object of both the sentence and the question. And then, after that, we looked for matches between the subject, verb, and object of the question and sentence from the document. So after we identified a list of possible candidates, we'll be using the NER tagging to find the most appropriate answer based on the question type. For example, if we have a question starting with when, then we might be looking for an answer that represents a time. And if we get a question that starts with where, then we might be looking for a phrase that represents a location. And after we find the most appropriate answer, we'll be using spacey dependency tree to extract the complete answer after we found the match. Sometimes the question might be a little bit complicated, which involves pronouns and passive forms. If we find out that the subject is a pronoun and the previous subject is not, then we'll assume that the current subject refers to the previous subject. We also do the same for the objects. And if either of the question or the candidate sentence is in passive form, then we reverse the order of the subject and object to increase our matching accuracy. So here's an example to consider. So suppose the question is, when was Pittsburgh named? And the sentence is, Pittsburgh was named by General John Forbes in 1758. The first step is to find the subject-verb-object pair in the question. In this case, the subject is Pittsburgh, the verb is name, and there's no object. And the second step is to find the possible matches of objects in our candidate sentence. In this case, we get two matches, General John Forbes and 1758. And now we look at the question, which begins with a when. So this is a hint that our answer should give a phrase that represents time. So among our two possible matches, we choose 1758, which represents the time. And that's our final answer. So that's the end of our presentation, and thank you for listening.